Hello, this is Mridula, and this is my Physics 2111 lab video, Experiment 3 Black Hole. The purpose of this video is to find the mass of the black hole using a computational model and to use the calculated mass of the black hole to find the initial velocity of the spaceship. So the preview is the mass of the black hole is 1.39 e to the power 34 kg, and the initial velocity is negative 4.26 e6, 5.9 e6, 0. The principles used in this video are Newton's second law of motion, which states that the rate of change of momentum of a body over time is directly proportional to the force applied. So net force is equal to delta P divided by delta T. And the gravitation law is force of gravity equal to negative g m1 m2 divided by the magnitude of the r vector square and then r hat, where the negative sign indicates that it is an attractive force. And I also use the velocity and position update formulas. So here p hat is the parallel component of force, which is parallel to the direction of motion, and n hat is the perpendicular component, which is perpendicular to the direction of motion. So net force is equal to the parallel component plus the perpendicular component, and the perpendicular component is mv square r by n hat, and the parallel component is p final minus p in initial by delta t into p hat. So the system is a black hole, the surroundings are the space and star. The mass of the black hole is 1.39 e to the power 34 kg. Mass of the star is 2 times 10 to the power 30 kg. And then delta t is 86,400 seconds for the total seconds in a day. So this is part 1 of my code, which is to find the mass of a black hole. So the mass of the star is 2 times 10 to the power 30, and then delta t, the number of seconds in a day, is 86,400, and the while loop calculates the x and y components of velocity. So inside the while loop, I edited the lines to find the change in velocity and change in momentum, and then I found the parallel component of force, which is p hat. And I did the same thing for the perpendicular component of force, and then to calculate the mass of the black hole, I did the magnitude of net force times the magnitude of the star position minus the position of origin to the power 2 divided by the mass of the star times g, and on the left side is the result. So the mass of the black hole for my code was 1.39 e to the power 34, and then you also see the total net force and the perpendicular and parallel components of net force. This is part 2 of my code. So the mass of the black hole as calculated was 1.39 e to e34, and then the constants, which is the same as in part 1, and I calculated and approximated the x and y components of the initial velocity of the spaceship, and as you see on the right is the result when I ran my code. So inside the while loop, I first calculated the force of gravity on the planet by the black hole, and then the force of gravity on the planet by the spaceship, and finally the net force on the planet, which is the force of gravity on the planet by the spaceship plus the force of gravity on the planet by the black hole, and then I calculated the net force on the spaceship. So it's like the same process: force of gravity on the spaceship by the black hole, and then force of gravity on the spaceship by the planet, and then the total net force, which is force of gravity on the ship by the black hole and force of gravity on the ship by the planet, and then the velocity, which I calculated. The initial velocity was negative 4.26 e to the power 6, 5.9 e to the power 6, 0, and the ship is 1.21 e to the power 12 meters away from the black hole. Then I used the velocity and position update formulas to update the position and velocity of the spaceship, and then this is a condition for if the ship gets sucked into the black hole or if it crashes to the planet. An error could be that I made mistakes in calculating the initial velocity of the black hole, as it is trial and error. So to answer the first question, the net force and the change in momentum are mathematically the same. So F net is equal to delta P by delta T. Net force is equal to the parallel and perpendicular forces on a system. And for the second question, the gravitational force on a spaceship due to the black hole should be equal to the gravitational force on a planet due to the black hole for the spaceship to enter an orbit around the black hole.